Good morning, and thank you all for joining us today. I'm Claire Lewis, and I'm the Florida Friendly Communities Statewide Coordinator for the Florida Friendly Landscaping Program. Today's webinar is Landscaping for Climate Change, brought to you by Professors Dr. Gail Hansen and Mike Volk from the University of Florida. And before we get started, I'd like to remind you all to fill out the exit survey before you leave today. So it gives us really valuable information on how we're meeting your educational needs and what topics are of interest to you. We'll continue to hold this webinar series on the second Tuesday of the month through 2021. Our next webinar is Introduction to Green Infrastructure. I'm kind of continuing on this same vein. It'll be held January 13th at 10 a.m. with Dr. Evan Beam. It is also approved for one landscape architecture CEU. So you may have noticed that your microphones have been muted. Please type your questions into the chat box, and we'll take questions pretty much at the end of the webinar, and maybe throughout it, but typically we wait till the end to take the questions. And this webinar has been approved for one landscape architecture CEU through DBPR. I have put a link in the chat box. If you'd like credit for this CEU, please follow that link and submit the $10 administration fee. And you can enter your name and license number in that location. I'll put the link back in towards the end of the webinar as well. With that, I'd like to turn the screen over to Tom Wickman to introduce today's speakers.
Thank you, Claire. My name is Tom Wickman, and I'm the statewide coordinator for the Green Industries Best Management Practices Program with the Florida Friendly Landscaping Group. Today, it's my pleasure to introduce our speakers. We'll start first with Dr. Hansen. Dr. Hansen is an associate professor in the Department of Environmental Horticulture. She's a faculty member in the Center for Land Use Efficiency and is a faculty advisor to the Florida Friendly Landscaping Program and an extension specialist in the sustainable landscape design. Her teaching and extension programs address sustainable, science-based, and art-centered landscape design practices that take into account the social dimension of green urban environments, environmental protection, and the quality of life for urban dwellers. Dr. Hansen graduated with a master's and PhD in landscape architecture from the University of Florida and currently teaches courses in residential landscape design and sustainable design. Our next speaker is Michael Volk, is a Florida registered landscape architect, partner in Volk Design Consultants, LLC, and a research assistant professor in the University of Florida Center for Landscape Conservation Planning, a department of the landscape architecture. He has a master's degree in landscape architecture from the University of Florida and a degree in architecture from Frank Lloyd Wright School of Architecture. Michael's work with the Center for Landscape Conservation Planning includes applied research on land use, regional conservation planning, and urban green infrastructure, the impacts of sea level rise on natural resources and coastal communities, and climate change adaptation strategies and information needed for landscape architects and professionals. Today, Dr. Volk will get us started, and then Dr. Hansen will follow. And today they're talking about landscaping for climate change. With that, I'll turn it over to Michael Volk.
Great, thank you, Tom. Appreciate it. Thank you, Claire. Yeah, I just wanted to quickly go over the topics that we'll be covering today. We're going to start by talking about just some basic ways that climate change is anticipated to impact the landscape. We'll talk about urban ecology and the way that human activities impact the landscape and potentially compound climate-related effects. We're going to briefly discuss ways of assessing and looking at the risks from climate change within the landscape and the role of green infrastructure in assisting with adaptation and responding to these changes. And we'll conclude by talking about performance data and ways of assessing, quantifying, valuing sustainable landscapes and novel landscape practices at a variety of scales that we can use to address these changes in the future. So I guess next, Gail. So I would imagine that a number of the people on this call already understand some of the basics about climate change and understand what some of these effects are going to be in the future. We're going to see both both physical changes that we can actually see, such as sea level rise and changes in morphology and changes in plant distribution. And there are also going to be functional changes that we're going to be experiencing in Florida, as well as throughout the world, such as changes in the levels of ecosystem services that natural communities are able to provide, shifts in biodiversity. And so, I guess some of the primary ways that we're looking at climate change, or anticipating that climate change is going to occur, is in terms of temperature changes, of course, which are generally going to be higher, but we're anticipating potentially to see less extreme increases in temperature in Florida. Precipitation changes, increased variability in precipitation, more extreme periods of drought and flood. I think overall in Florida, we're looking at a possible slight decrease in the amount of precipitation, but again, probably greater variability, and in part due to changes in storm events and potential for an increased number and strength in tropical hurricane events. Of course, sea level rise is one of the primary climate-related impacts that we talk about in Florida and in coastal areas in general. And so estimates vary, of course, and it will also vary depending on where you are within a coastal area and whether there's land subsidence occurring. But we would anticipate at least a minimum of 1 meter of sea level rise by the year 2100 and very possibly more. Sea level rise is already occurring. This is a slightly older output from the tidal gauge in Cedar Key, but we're already seeing sea level rise occurring over the past century, and that's only going to accelerate. Also, saltwater intrusion is already occurring in Southeast Florida, and saltwater is going to impact underground water resources and potentially also landscape-related resources above ground due to increased salinity changes. Next. And the changes, like I said, are already occurring. This is a really interesting set of diagrams that compares shifts between plant hardiness zones from 1971 to 2000 when compared to 1981 to 2010. And this is a result of the update to the plant hardiness zone maps that occurred in 2012 when compared to the 1990 maps. This is based on Noaa data, so it's not USDA data, but it's similar, and you can see in colored areas where we're already seeing a shift towards a warmer plant hardiness zone occurring on the left. That's where a shift has already occurred. And on the right, where a shift is anticipated to occur over the next 30 years. Go ahead, Gail. And so just to quickly summarize, we're in terms of the specific climate-related impacts that we are anticipating to occur on plants and within the landscape. There's a lot of detail that we could go into about each one of these and research that's currently being done right now on these changes. We're seeing shifts in blooming periods, in when plants are putting out leaves, when they're dropping their leaves, when they're putting out fruit. We're already seeing those sorts of changes occur in different ways throughout the country. Definitely changes in distribution and species distribution. One of the things that we've documented and that I did a little bit of research about for one of our publications was the shifts in mangrove distribution further north along the coastlines in Florida, and mangroves moving further north than they have been in the past. Also, coastal die-offs of less salt-tolerant species already occurring along the coast. And this diagram on the top right kind of diagrammatically shows how those changes are occurring along the Big Bend coast around Cedar Key, whereas salinity levels increase due to rising sea levels and increased storm events. Those coastal forests that have a lower salinity tolerance are starting to die and convert to transitional salt marsh. And so you can see in green, the kind of diagrammatically, areas where those coastal forests are, and around the edges, those trees and species dying off and converting to salt marsh, and then open water in some places as well. And we're also anticipating, as these changes in distribution occur, also increased levels of invasives and exotics and potentially pests that we'll have to deal with within the landscape. Next.
Okay, so as Mike said, we know that climate change is happening, and one of the issues is that climate change has numerous impacts on landscapes, and they're actually more pronounced a lot of times in cities, in urban areas. For example, we have the urban heat island, which is a well-known phenomenon that is associated with climate change in cities. So I thought it would be helpful if we talk a little bit about urban ecology, because urban ecology is a relatively new ecological science domain in the long history of ecology science. It is different from conservation ecology or wildland ecology, and that's because it involves humans. So in urban ecology, we're really talking about three interconnected systems. We have the natural environment, which is, of course, is the soil, water, vegetation, and so forth. Then we have the built environment, which is roads and buildings, but there's also the social environment. And the social environment is people and all the things they do, all of their activities. And what we're really talking about is this coupled relationship between humans and nature in cities. So it's a much different dynamic than you would find in natural areas. Urban ecology tends to be more forward-looking as opposed to conservation ecology, which tends to look back when they are talking about restoring to its original habitat or original ecosystem. And the reason why urban ecology has to be more forward-looking is because we're trying to balance the economic, ecological, and the human well-being. And not just for today, but also for the future. And the other reason why it is very important is because we need to take that ecological science that we know about ecology in cities, and we have to link it to all our civic processes and our policies, again, so that we can make our urban areas more livable, and for not only the well-being of humans, but the well-being of all the other animals, insects, birds, and so forth that live in our cities. And quite a few of them do, actually. For example, in our civic processes, in our development codes, we need to consider all the ecological science in the city. So this diagram that's on the right is, I recently wrote a book with a co-author on urban ecology. And what we were trying to do is we put together this diagram to figure out how we were going to organize our book and really look at all the issues that we needed to address in the book. And so we have the base of ecology, which is soils, hydrology, wildlife, vegetation, and so forth, and also environment. Those two are our base because cities are obviously built on land, and all of these issues are still within the city, although we actually destroy a lot of it. But we also wanted to put more emphasis on the social and the cultural aspects of urban ecology. So you see we have things like environmental history, biophilia, our values, beliefs, our norms, and our ethics around landscapes, the social influences, and so forth. And we also have the cultural side. We have a lot of legal landscape issues. We have a lot of codes and ordinances with landscapes. And then there's meaning and identity wrapped up in our landscapes and our aesthetic preferences. And then you see this whole bunch of arrows going right toward the middle. And right in the middle there, that's where the climate change kind of falls as far as the impact of human activities, our landscape behaviors, and we're looking at different scales like neighborhood scale, residential scale, and then also considering performance data, which we will talk about a little bit later. So urban equality and climate change, what do those two things have to do with each other? Well, many urban ecologists believe that ecology is going to be the key to saving our cities in the future. And as you can see by the small picture on the left, cities are leading the way in climate change action. They're not depending or waiting on the federal government or state governments to help their cities in, their climate change actions that they need to do. They are just, mayors of cities are actually leading the way. And the other thing about the urban ecology is the key factors are going to be biodiversity and functionality. So we need to have biodiverse landscapes, but they also need to function. And in the way that they function, they need to provide ecosystem services, because that's how we look at ecology in the cities. What types of ecosystem services will we gain from them? So we're also going to talk a little bit about novel landscapes, and those are landscapes built by humans. And in the cities now, a lot of these novel landscapes are built specifically to mitigate climate change impacts. And we can look at these at the city scale, the neighborhood scale, and at the residential lot scale. So urban ecology really is kind of tied together with the impact of human activities. And a lot of our activities are not good in cities. We have a loss of biodiversity and habitat, more invasive species, a lot of disturbed soil and hydrology patterns, and of course, chemical pollutions. So those are a lot of the things we are trying to fix with our novel landscapes in the city. And these are some of the mitigation strategies, of course, that we are learning to do and using more of. Besides novel landscapes, invasive management, because that's a big problem in cities, both integrated pest management and integrated vegetation management, soil management plans, stormwater technology like sponge cities. And I put this picture on here because I was really quite fascinated by this idea that we could get electricity from plants. And this was a project that was developed in the Netherlands, and they've actually figured out a way to get electricity from plants that they put up on green roofs. That's where they're using it mostly now, in green roofs, but they also plan to use this same system in like rice paddies and so forth. And really, it's just about putting carbon electrodes in the soil and then using the decomposition of organic matter to produce electricity. So I thought that was a very innovative idea, and just wanted to show that to you as an example of some of the ways that people are thinking about mitigation strategies for climate change. So the key factor, though, in urban ecology is biodiversity. It is the cornerstone of a resilient and a sustainable ecosystem. So that's why it's so critical for climate change adaptation. And I'm sure that everybody here knows that that is a biodiversity is short for biological diversity. And we're beginning to look at biological diversity a little bit differently. It used to be it was just talking about the number and diversity of species in an ecological system. And so the thought was, well, if you had a lot of species and they were very diverse, you were good. Not so much anymore. Now we look at functional trait ecology, and that's looking at the different characteristics of each of these species and the things that they do to keep an ecosystem healthy. And so you're not only just saying, well, I have a lot of different plants, but what will these plants do to support insects or to support birds or wildlife or for human well-being also? And there's a couple of things that science is still working on in terms of biodiversity. And one of them, especially in the cities, is we're studying, but not quite there yet, on how to rank the importance of the different traits that these plants have. And we don't know yet what the optimal combination of plants animals, insects, and soil microbes, and all the other animals that might be in a landscape. We don't know what that optimal combination is yet. But we do know, surprisingly, that cities can support a very wide variety of diversity. We do have a lot of different plants and animals in cities. The problem is, though, a lot of them are just plant collections. So we all know how plant collections happen. Homeowners or people who are doing designs for, say, commercial properties and so forth, just go to your local nursery and you buy a bunch of different plants. And so you have a big number of plants and you have a diversity of them, but it doesn't necessarily mean that there's trait diversity within those plants. So we can't trust that just because you have a plant collection, it's really good for the environment. Residential yards, for example, could be a really important stepping stone or microhabitat for for animal and insect and bird species that are mobile and can move around, but they won't be if you don't have the right type of plant in your landscape. One of the challenges, though, with creating biodiversity is that you really have to do your research and figure out what each of these plants actually, what their traits are, their functional traits are, and that's not always easy to find. So that's a big challenge in the idea of functional trait ecology.
Yeah, so thanks, Gail. I think that, just to, to underscore what Gail is saying also and bring it back to climate change, we're understanding more and more the importance of urban environments and what we're doing in urban spaces on mitigating climate-related impacts to biodiversity. And some of the research that is ongoing right now is starting to inform our understanding of that. There's work by Doug Tallamy, including his book, Bringing Nature Home, a recent book on climate-wise landscaping by Steibold and Reed. So researchers are looking at, well, how do we maintain biodiversity in our urban landscapes as climate change begins to occur? And how do we actually support biodiversity in our landscapes? And one of the things that Gail and I have worked together on with additional partners in the Department of Landscape Architecture and students is a resource and an initiative for sharing information about climate change with the landscape industry. And we have a screenshot here shamelessly promoting. You can see there's a link, and I've got a couple other web pages here that I'll provide links to. But this includes basic information about climate change and web-based resources for looking at and identifying what the specific impacts are going to be in different regions and portions of the state. We also include information on projects and plans that landscape architects are already doing and they're already built that are specifically designed to address climate change. And then strategies that are broken down based on different components of the landscape, like hardscape design, planting design. Still a lot of work to do, and this is an ongoing project that we're continually needing to update. One of the issues when it comes to actually assessing climate-related impacts and figuring out, how they're relevant for the landscape industry is, the information is still being developed as we speak, and we're still seeing these changes occur. And B, it's hard to, I'm sure there are others, but it's hard to find and create resolute and detailed enough information that can be used on an actionable basis by landscape architects and people working at a smaller scale. And so we've tried to collect some of those resources, and I'm sure that they'll continue to develop. I guess, go ahead, Gail. Just as an example, one of these web-based resources that is available is the Noaa Coastal Flood Exposure Viewer. And this helps map a variety of different layers. We're only showing the hazard layers here on this slide. and you can overlay them. You can map sea level rise, and you can map different levels of sea level rise to see what those impacts are going to be, FEMA flood zones. But it also, if we were to scroll down, which we can't do, it also includes information on societal exposure, employment information, infrastructure vulnerability, critical infrastructure, as well as ecosystem related changes as layers that you can toggle on and off on this. And so, you know, quantifying this and figuring out how to use it is another step, but this at the very least begins to help us, you know, visualize some of these changes that may be occurring in the future or will likely be occurring. Go ahead, Gail, to the next slide. Another resource that is ongoing, currently developing, is, and I guess maybe to back up a little bit, there are agency-related, there's agency-related information, things that federal agencies, the state, local governments, universities create, like the Noaa flood exposure map and viewer. But there's also this concept of citizen science that can be used to inform our understanding of changes in the landscape. Citizen science basically being data that citizens and individuals collect that can be collected and combined to inform our understanding of what's happening. And citizen science is being used on a variety of levels to essentially crowdsource data and information that we can use for a better understanding of changes. And this is one of those examples, which I think is really interesting. It's the National Phenology Network. There's a visualization tool that you can use here to look. You can search for specific types of trees, and people are mapping and geolocating, you know, when are those trees flowering or when are they losing their leaves on different years, and you can collect and download this data. I think that there's still a lot of work to do on this. There's still, you know, some clear gaps and things that, you know, we're seeing that there's maybe limited data for certain types of things that you're looking at. But if you go to the next slide, Gail, this is one of their pre-made maps that shows where spring, like the leafing out of trees, is arriving earlier or later compared to a long-term average. And so we can see in red where spring is arriving earlier based on the data that they're collecting, and where it's arriving later is in blue, earlier is in red. And so in North Central Florida, you know, for example, where we're located, it's saying spring is arriving earlier, and anecdotally, maybe I would agree with that. But this is one of those examples of ways that this sort of crowdsourced data is being mapped. And the second link here, Nature's Notebook, actually takes you to the site where you can learn how to sign up and be part of this effort to record and share data about changes that are occurring. There are a number of these projects that are going on. One of the links that Gail actually shared with me this week is this Size Starter link, which is an organization that is collecting and kind of creating a library of these citizen science projects. Project Budburst is similar to the National Phenology Network. They're doing sort of similar work about mapping distribution changes and changes in phenology. iNaturalist and eBird are a couple of other examples that are looking at these changes. eBird is a site where you can identify a species and then record their location and when you saw them. And so we can start to map changes in bird populations also over time through these methods. Go ahead, Gail. So we have, I don't think that we have a perfect way of assessing risk yet from climate change or really understanding everything that's going to occur, but we're starting to see resources be developed that we can use to identify what these changes are going to be. And I'm seeing a few comments showing up on the bottom of the screen here. We can share some more of these links and information that we're going through quickly now. I think after the presentation, we can talk to Claire and Tom about how best to do that. So, green infrastructure and what we do within the landscape has a role in terms of improving and mitigating the impacts of climate change. I think probably something that people are aware of already is this idea of green infrastructure, if you're on this webinar. But, our understanding is that green infrastructure can exist at multiple scales, at the scale of a city or a county or a region. It refers to those natural areas that provide habitat, flood protection, various ecosystem services, usually a network of open spaces that combine to create functional benefits within the landscape. But we also talk about green infrastructure at a very small scale in terms of stormwater management and green streets and low impact development strategies, rain gardens, these specific sorts of design tools that we can use as landscape architects, landscape professionals to improve stormwater management within the landscape. And they also have a role in mitigating climate related impacts. Next slide, Gail. We don't have to talk about this in detail, but this is just a chart that kind of demonstrates the fact that different green infrastructure based strategies and tools like green roofs, bioretention and infiltration, use of permeable pavement, these tools are on the left side, and on the top edge of that chart are the specific benefits that each of these strategies have, related to, livability, stormwater, ecological benefits. And so if we can find ways of using these practically within projects, we can potentially create a number of benefits throughout the landscape that are climate and non-climate related. One of the specific, well, I guess next slide, Gail. Some of the specific ways that, green infrastructure can mitigate and help, reduce the impacts of climate change and maybe even convert them into positive things within the landscape are, through mitigating heat island effects, for example, within urban environments. It goes very simple, the idea of planting trees, but we can increase shade, reduce solar gain, reduce, the amount of heat that's bouncing off of concrete surfaces by increasing the amount of green infrastructure within cities. Also, we can have a huge impact on the ability to mitigate flood-related risks within urban environments by increasing the amount of space where water can recharge or where it can be temporarily stored during rain and storm events. Because as we start to see these changes in precipitation and storm events, we're going to start to see more, intense rainfall events, and that's something that we can help mitigate through stormwater management strategies and green infrastructure. Obviously, also there's a benefit for biodiversity if we do it right, and we use species that can enhance those, that have those functional traits, that do provide those biodiversity related services like habitat, food sources. Also we can benefit water quality and water availability through the use of green infrastructure by filtering out nutrients and pollutants, and enhancing our protection of upland areas when we're thinking about sea level rise and erosive events and storms. We have to be very careful about how we manage and treat shoreline areas. And green infrastructure based strategies like living shorelines are one of the ways that we can manage coastlines so that we can help provide additional protection for upland uses, but still maintain biodiversity and other natural functions along the shoreline. So we have a role in the landscape industry in terms of how to adapt and manage climate related impacts.
So I wanted to talk a little bit about landscape performance data. as Mike was saying, that many cities are using green infrastructure, and we actually do know a lot about how to design some of these facilities, like stormwater facilities, as a climate adaptation. But one of the kind of new areas that we are looking at is collecting data on how these landscapes perform. And the reason why we need to do that is because we need to learn how to improve those landscapes. And the only way that we can do that is if we know kind of the before and after metrics and how they perform and what we need to do to improve them. So the Landscape Architecture Foundation has developed a program, and it's basically called Landscape Performance Data. And you can go on their website and get all sorts of information, including their guidebook for metrics and methods that they have posted on their website. But I'm just going to very briefly tell you about the program and show you some of the case studies that they present in their guidebook. So landscape performance data is pretty much exactly what it says. It is information on how that landscape performed, and it measures how well the landscape functions. And those measurements can be done either environmental, social, or economic benefits. And one of the big reasons why we want to collect this data is because we need to know if we need to improve the landscape, but also the data is used by planners, landscape architects, designers, and so forth to measure the return on investment benefits, and also to just see what the feasibility of a lot of these green space projects, the feasibility of actually installing them. Will they work? Is it worth the cost to install them? A lot of cities are in a position where they don't have a lot of funding, again, from the federal or state government. And so they're looking very carefully at their budgets, and they want to make sure that whatever they do in terms of like stormwater management, planting more trees for urban heat island abatement, things like that, what are the benefits for what their investment is? So how do we collect landscape performance data? Well, you need to have specific performance objectives. What do you want the landscape to do? You need to build a landscape that has functional goals attached to it. So I'm just going to use an example here of a very small residential lot scale, but landscape performance data is typically used in large city projects, city parks, but also can be used citywide too. But just to make it simple, looking at the data that you might collect for a bird habitat, for example, in a residential lot, you have to have before and after metrics, obviously. So before you are going to create this bird habitat, you would want to observe the number and the type of birds that are currently using the habitat. And then you want to establish some specific performance objectives. One of them would be simply on this one, increase the number of birds that are using the space and increase the different species of birds that are actually using the space. But what we really want to measure here is we want to measure the outcomes. You want to keep track of your output. So your output would be, for example, the number of trees or shrubs or ground cover that you are planting to create all these vertical layers that we know are necessary for bird habitat. We have birds that are ground dwellers all the way up to the top of the canopy, and some of them go up and down. So these vertical layers of vegetation are really important. So you do want to keep track of your output, which is the type and number of trees and shrubs you plant. But then your outcome is really what benefits did you provide for the birds, the food, the shelter, nesting, and to see if it works, then you're going to have to start counting. You're going to count the number of birds that you see and the number of different birds that you see. And if you didn't get any more birds than you had in your before measurement, then you didn't do something right, and you have to go back and reevaluate and change your landscape. And so that's just an example, simple example of how you would go about collecting performance data on a landscape. So I wanted to show you a couple of the case studies that they present and in their guidebook. So this one in particular is a good one to show environmental benefits. Environmental benefits could be stormwater management, water conservation and quality issues, creating habitat or protection of habitat, and also looking at air quality and temperature mitigation. So in this particular one, we'll look at stormwater management because this is an example from New York City at the Dutch Kills Green. This picture shows after they had changed an area that was completely paved over. It used to be a big parking lot and loading dock area, so nothing but asphalt and concrete. And what they did was they came in and they changed about 35,000 square feet of land and reclaimed it as a green space. And some of their goals were to collect, look at or measure the volume that they could hold in this area and the percent runoff that they could retain. And one of the reasons for that is they really needed to reduce their peak discharge because they were having flooding problems with their stormwater or their sewer system in the city. And the other thing that they were interested in looking at on this particular project was reducing their infrastructure and treatment costs. So by reclaiming this as a green space and making these stormwater collection areas, they were able to keep a little over 20 million gallons of stormwater from going into their sewer system. They were able to prevent flooding. And in the end, they saved 3.4 million in their infrastructure costs because they did not have to go back and enlarge the sewer system. They were able to handle the volume of water just through this, this green area. A couple more examples are, excuse me, are social benefits and economic benefits. When we think of social benefits, we're thinking of what can people do? So recreation, cultural preservation of landscapes, improving health and well-being, opportunities for people to be in nature, and also educational opportunities. Education in this case could be measured by the number of people who visit a site, attendance at educational events, number of people who use their educational material. For example, the picture here of the Cornell Plantations Welcome Center, people reading their brochures and looking at their signs, and also an increase in knowledge. So at Cornell Plantations, what they did is they do periodic surveys of the people who come to the Welcome Center. And of course, they ask a lot of different questions, but on one particular question, they found that almost 60% of the survey respondents were able to correctly answer at least 7 out of 9 questions about the bioswales that they have there at the Welcome Center and that they have information about. So that's just a very typical example of one of many social benefits that people can get from urban green spaces. Cities, on the other hand, are almost always very interested in the economic benefits. And they could be an increase in property value, a decrease in operation and maintenance costs. They look at construction costs and also the ability to increase economic development. In this particular case, here at Carmel Clay Central Park, which is in Indiana, they were really interested in their operation and maintenance costs. So they wanted to know savings on water, energy, and maintenance. The data for this is fairly easy to collect because they can just look back on records of how much water they use, their energy costs, and so forth. And what they did here at this Central Park area was they replaced all of the turf in the park with native plants, and they were able to save $54,000 in annual maintenance costs, which is a significant savings. And most of that came about with savings on water, a lot less irrigation, and also savings on the maintenance. The native plant fields that they planted didn't require nearly as much maintenance as the turf. So now we have this performance data that we are able to collect, and we have projects where they are collecting this data. And one of the reasons why we need this is because all landscapes in the city are novel landscapes or novel ecosystems. And that means that they're ecosystems that are built by humans. And we use our ecological knowledge to build these landscapes, but then we need to test them. We need to collect data on them to see if we are doing it right, basically. Because these human-built ecosystems are a little bit different in structure and function than the natural system would be, like a wetland, for example, as stormwater treatment. And it's also managed biodiversity, and that biodiversity is managed by us. We're the ones that create those landscapes, and so we have to have knowledge of biodiversity, and we can do our best to try to figure out what combination of plants we need for that biodiversity, but then we need to do collect that performance data. So we have these hybrid systems, and we hope that they function a lot like natural systems. We really want them, the goal is to provide ecosystem and cultural services, because we do have the social side of this too. And the way we create these novel ecosystems is we use new combinations of animal or plant species. And a lot of times it makes it unique from other ecosystems which happen to be in that same biome. So it's really, our ecosystems, human-made. And we tend to do more a mix of the alien and native species, because we do tend to find, and studies have shown this, that because the soil is often very disturbed, the hydrology is disturbed, we have different temperatures in cities. The temperatures fluctuate a lot in different parts of the cities. That if you use both alien and native species, your landscape will provide more ecosystem services, because you will have a mix of plants that may be better adapted to those disturbed conditions, plus the native species, which may not thrive as well, but they still provide more ecosystem services. So this is another case study that was in the guidebook, and it's a development in Utah, and they used a lot of native and drought-tolerant plants in this development. They set aside habitat conservation areas. Their stormwater management systems were more natural systems. They were still human-built, but more natural, meaning it wasn't piped system. And one of the other ways that they helped to conserve energy in this particular development is they grouped the houses very tightly and developed their road system. So about 90% of the kids, the students who live in this development, can walk or ride their bike to school. So that was, part of this whole, the development goals were to reduce energy consumption, and also clean air was another goal as far as getting more people to walk or ride their bikes. So what do novel landscapes have to do with climate change? Well, we create these landscapes, so it's our opportunity then to create landscapes that will help mitigate climate change stressors in the city. Things that we want to be able to do is provide ecosystem services, but we want to clean the air and the water. We want to regulate the climate, mostly temperature. And we want to provide pollination for insects, and we also still want to provide recreation for people. So when we design these landscapes, three things that we really need to pay attention to. We need to use plants that have a wide tolerance ranges, plants with more plasticity. For example, in this picture here, it's Lake Beauty Park in Arnold Palmer Hospital. And it's a totally man-made landscape. But as you can see in the picture, the small picture down in the bottom right, it used to just be an all turf bank down to the pond there. And then in the new pond, they have aquatic vegetation, they have native plants for pollinators, they have bank vegetation and so forth. And one of the issues with ponds like this is oftentimes the water levels rise and fall. So you need to have plants that are not only tolerant of very dry conditions, but also tolerant of very wet conditions. So using many different types of plants that can tolerate these different conditions will make our urban landscapes a lot more functional and provide these ecosystem services that we're looking for. You also want to use a broad mix of species to increase that functional redundancy. So we have plants in there, for example, that are plants for pollinators, but you don't want to have just one plant for pollinators. You want to have several plants because then if one plant fails, you have other plants that can take its place as far as function. So functional redundancy is really important in these landscapes. You also want to use species from a very wide variety of environments, and that way you can increase this likelihood that you're going to have more resilient species that can adapt, especially in your native plants that can in some way adapt to the disturbed soil or lack of water or temperature fluctuations. And that's just to ensure that your landscape is going to be more successful, because one of the things with human-made landscapes is we need them to thrive. We need them to be successful in order to provide these ecosystem services. At the park and the residential scale, some of the things that we have found, studies have found, and with people who are working with these different landscapes, is that one of the things that you should consider is that if you're thinking about using native versus non-native species, base it more on the impact that that particular species will have and not so much the origin of the species. Usually it turns out that you're better off to use the native plant because they do have a greater impact. They do support more insects, they do support more animals, and they do work better, for example, in wetland type environments. So usually the way that it kind of shakes out as far as impact is the natives are better, but you should use a variety because there are non-native plants that may have an impact in another area where the native plant may not thrive due to, disturbed soil or something. Management practices are also very important. You can't just put all these native plants in and your non-natives and just expect them to, especially with native plants, to thrive and be on their own. But you also don't want to decrease your biological richness by, say, for example, spraying for insects and killing all the good insects along with the bad. Another thing that we have to recognize is that humans are really good at dispersing seeds and dispersing plants. They move plants all the time. We dig them up and move them around. So that is a significant factor in your biodiversity. We just need to pay more attention to the impacts and the functional traits of these plants. And that's not to say that aesthetics is not important, and it is very important in the urban environment because most people do judge a landscape by how nice it looks, and they accept landscapes more and are more willing to, have those landscapes in their environment if they are also beautiful landscapes. And we can't forget that there is other urban nature, and that other nature is usually like those big recreation parks where there's just a huge amount of turf and there are sports fields or play fields. And their worth might not be in the biological richness, biodiversity worth, but they have a lot of worth in the social value. So we can't discount those other urban nature green spaces. So just a couple of other, almost done here, a couple of other really quick concepts that I wanted to talk about is national park cities. And this is really interesting. Some of you may have heard of this. London was actually the first city to be certified as a national park city in 2019. And the concept there is that you kind of flip the idea of, instead of having parks in cities, you have a city within a park. In order to do that, though, you have to have a lot of green spaces in your city. So in London, there are a lot of green spaces. They have a lot of front gardens, which is essentially a front yard. Green corridors, outdoor classrooms, created wetlands, historic parks, and ancient deer parks and so forth. And all of this in London adds up to about 50% of Greater London being physically green. In London, they have about 3,000 parks. Their greenways stretch to about 1,000 kilometers. 20% of their green space is designated as nature conservation areas, with 142 local nature reserves. And they have identified 1,400 sites of importance for nature conservation. And the amazing thing is this is all done in a city that has close to 9 million people in the city. So it's a good example of what can be done in a city as far as green spaces. And of course, in England, they have a very rich historical heritage of green spaces and gardening, and it's reflected here. So other cities are beginning to look at being certified as national park cities. And I just thought it was an interesting concept that you might like to hear about. And one last thing about novel landscapes. They don't always have to be associated with a green space. So here's another thing that cities that have a really high dense urban core with a lot of concrete, a lot of asphalt, is these water plazas. And this, the first urban core water plaza was developed in Rotterdam in the Netherlands. This has been a while ago in 2014, but I think it's an interesting concept and worth considering in the big picture of ecology in a city. So they were designed to store stormwater, and it was an unused urban plaza, and they went and they redesigned it so they lowered some areas. And you can see in the picture there an area that looks sort of like a basketball court and another blue space there. What they did was they excavated down and lowered them. And now they have two areas where they collect over 500,000 gallons of stormwater. Then they do have drains out of these areas. They slowly drain these areas and pipe the water out to green spaces to actually filter and clean the water. But during the dry season, these flat areas are actually sports areas. One is used for basketball. The dark blue one is the skateboard area. And you can see that there are steps on the side. They use it for an outdoor theater. And so I just wanted to show you this to say that they are using climate adaptation mitigation strategies, and they are working for them. And it's not necessarily always with a green space, but adapting a very hard surface area to their needs here. And so I'm ending with this particular slide, and I think we're just about out of time. So Mike and I would be happy to answer any questions that you might have. And I'm not sure if Claire is going to be directing those questions to us.
I'd be happy to. There's a few in the chat box. One asking for the links that you were talking about earlier, Mike and Gail, on the climate change.
I can provide those. I was actually just working on copying and pasting them, and I'll put them in the chat in just a second.
Wonderful. And we don't have people register for this, but I can send out information if people are interested in that. I do, if they put it into the I guess when they registered. But one of the questions is a single residential home in a small town considered urban? Does urban just apply to cities with larger populations, or is the definition of urban more flexible?
I would say that the definition is more flexible. Really, the distinction is between rural areas. Some people might consider a small town to be kind of that line between rural and urban. But I think more, a better way to kind of quantify or qualify that is to say, if that yard is developed, designed and built or installed by humans, by people, if it's a man-made landscape, then it would kind of fall under that urban category, because whoever designed it and built it is the person who is dictating what happens in that landscape and what ecosystem services that landscape might provide.
Very good. Then there's another question from Bryce. In South Florida, as we pushed into zone 11, what criteria should we be using to bring exotic tropicals into our novel ecosystems?
Exotic tropicals. So exotic tropicals are probably being asked for from the aesthetic standpoint. People are, because a lot of people see all of Florida really as a tropical area. And a lot of people who move into Florida are have an expectation to see more exotic tropical plants. I think that you're probably going to see more available in your local nurseries that you'll be able to use, but so that is kind of supply and demand issue there. But I think we should try to think in terms of maybe not exotic, but what are some of our native tropicals that possibly could be used in that area. I know that sometimes in local nurseries, they're not always available. And that's one of the problems with using natives, is the supply is not always there. Mike, you could probably add some more to this, because we've been having conversations about this for a while.
Right. Well, I think the only other thing that came to mind for me, and actually you might have just said this, Gail, because I was looking at the links that I copied here, but is obviously that we want to avoid invasive plants. And so I think the idea would be to go back to what Gail was talking about in terms of their functional traits as an exotic, and to see if it makes sense from that perspective, and also from the perspective of something else that she talked about, which was essentially how flexible they are to future changes. We want to be using plants that can be durable during periods of drought or precipitation, and potentially also changes in salinity, as we start to see saltwater intrusion occur more, in certain areas. And then certainly to avoid using species that are invasive or borderline invasive.
Yeah, so one of the other issues with that is thinking about if we overuse some of these exotic tropical plants, we don't really know much about their invasive potential until they get overused. And then that's when we start to see the spread into natural areas and so forth. So I think about using caution about overusing some of these plants.
The next question is, I've kind of scrolled through it, but they wanted to know if there was any other national park cities in the United States, if there were any.
Not that I'm aware of. I don't think any has been named a national park city yet, but I believe that actually New York may apply for that. People often find it amazing about how much green space is actually in New York City, and it's quite a bit. And one of the reasons for that is in the in the city boundaries. The city itself is very dense and compact, but it doesn't take up, all the buildings and everything don't take up as much room in the city boundaries as people think. And so there is quite a few parks. In fact, New York City has had several awards and certifications for a highly sustainable green city, and they have their 1 million tree program. And they do have a lot of wetland areas that they have conserved, and they use the Staten Island Blue Belt is one of them that they use for green spaces. So I think they probably do qualify, and they may be applying, but I don't know of any other cities in other countries.
There's a question. Gail mentioned an upcoming book publication on urban ecology and the citizen scientist. When will it be published?
It takes an amazingly long time to get a book published. So my co-author is Joseline Macedo, and she is a professor up at Dalhousie University in Nova Scotia. We've been working on this book for 2 years. It should be out, it's in press right now, and it should be out in early fall next year. And so it's a book about urban ecology. We aimed it at the ordinary citizen and at citizen scientists and at planners. So it's written in a way so all of these issues are understandable, not a lot of scientific jargon, but very understandable. If you want to learn more about your city and participate in citizen science, we present a lot of citizen science projects in the book and give a lot of different examples. So hopefully we're looking at it being out in early fall.
And, I think if you two don't mind, we'll kind of continue going through some of these questions. If that's all right with you two. Mm-hmm. Okay. And certainly we're past our 12 o'clock mark. So anyone that dropped off, that's fine. One of the questions is, are there any resources that are geared to homeowner education? And I would probably just send them to our website, and we have some great webinars also geared towards homeowners. Maybe you two would like to add on to that, but I will put the FFL website in the chat box right now.
Yeah, I'm trying to think off the top of my head. I think the Florida Friendly website is the best way to get information specifically for homeowners. There are books out there, for example, and our book that we're writing actually is geared towards citizens, ordinary people. But Mike, you had one that you mentioned that I'm trying to think of her name right now. You listed her book in.
Oh, Jenny Steipel
yes.
And Sue Reed, and that's specifically climate-wise landscape, resources. It's really accessible and easy as a book. I would certainly defer to you, Gail, and Claire about the Florida-friendly resources, but the other one that I always thought was really pretty easy from an accessibility perspective was the floridayards.org website, because there are a number of Florida-friendly resources. And so I feel like that's a useful one. And Gail, you've put together different publications in the past as well.
Yeah, so some of the EDIS publications that I've written are helpful. I also think that if you look at the Landscape Architecture Foundation landscape, at the performance data one, it's actually fairly easy to understand. And I think if you go through and you look at all the information that they have there, it gives you a really good background on performance data, how to do it, how to measure it, and why it's important. And it's just a good basic background information too. And I don't know if we've got that. I know I put the name of the book in the presentation, but I don't think I put a link to it. If you just type in Landscape Architecture Foundation performance data, landscape performance data, you'll go right to the website.
I think it's landscapeperformance.org.
Is that what it is? Landscape? Yeah, that's what it is. Landscapeperformance.org.
And I don't know the specific link to the publication, but I think it should be on there.
It is. It's on that website.
Sorry, I'm taking notes while you guys are talking. Jump back in here. So there's another question that's interesting. Do you see cities becoming living cities with urban gardens in the streetscapes or edible landscapes? also love the idea of cities within parks. How do we get the zone codes to work to get the developers out of the cookie cutter building designs and avoid politics?
Oh, yeah, that's a tough one. That's one of the issues with biodiversity in cities is the cookie cutter type developments. And we're really actually kind of depending on the individual homeowner once they move into those developments to start planting more plants in their front and backyards to increase the biodiversity and create these bird habitats and pollinator gardens and so forth. Um, so, yeah, I mean, as far as some of the development, what was the question? Development policies and some of these other.
How do we get the zone, and I think the zoning codes to work to get developers out of the cookie cutter approach?
Well, and that's one of the things about this performance data is we are trying to look at these landscapes that are being built for their return on investment. And if you can actually prove with this data that you are getting a really good return on your investment in many different ways, it could be, again, environmental, economic, social, then these landscapes begin to have a tangible value to city planners and also to the developers and the people who are going to put their money into these projects. If you can say to them, look, you know, you're going to save this amount of money in your maintenance of this property. Those very tangible things are what's going to convince those developers that this is something that we could do and that we should do, and we will benefit from it also.
Wonderful. So I think there's just one more. It was to deal with the soil. Let me find it. Sorry, here's one that I missed too. Can novel landscapes be incentivized for developers to be more inclined to implement? And that's probably goes back to what you just mentioned about performance data and
yes, and that's where we would use that performance data. And we can incentivize them. A lot of it gets back to maybe not so much. And we know that a lot of times these novel landscapes are sometimes more expensive initially to install. So a developer would look at that. But then looking as time goes by on the maintenance aspect of it, and also the durability of the landscape. How long will it last? And this idea that in this development, people are going to want to live there because they are going to get a lot of social benefits. People want to be in nature. We have, biophilia, that is the human need for nature. People like to be in developments where there is a lot of nature, trees, where they see birds and other wildlife. And our values and our beliefs and our norms about landscapes, we know that people highly value nature and green spaces. And if you can convince a developer that by making these green spaces more biodiverse and having more animals that people can see and interact with, will sell their lot, and people will want to live in these developments. And that's, again, going back to this performance data and that creating that landscape that attracts more birds. People are very into watching birds and hearing birds. And so if you can convince a developer that people coming into your development and looking at your houses are going to be really attracted to these types of landscapes, and people are willing to pay more for green spaces. So I think that, again, it goes full circle, the performance data, the proof that you can. Also, developers can usually sell lots for a higher value. Property value is higher if you have some nice big trees and green on it.
Yeah, and there is data for that.
Yes.
Well, I think we want to thank both, Gail and Mike. We want to thank you so much for putting on this presentation today. There were lots of, very high praise in the chat box too, Gail, if you didn't get to see that.
Oh, I haven't looked at it.
Yeah, people have enjoyed the presentation, and
Okay.
the links are in the chat box. What I can do for anybody who's still on is I can send out an email with all the links to it, and I can just send it to everyone who put in their email address, realizing some people may not want this information, but you can delete it. Try not to spam people, but well, thank you very much.
Mike, Gail, thank you so much.
Thank you,
Okay.
Claire. Thanks, Tom.